This is a quick little video to show you how to write an alpha decay equation for a particular radioactive isotope. We're going to use Americium 241, and you might have been asked in your nuclear survey if there are radioactive isotopes in smoke detectors, and here's a clarification for that one. Yes, there are. Americium is an excellent what we call alpha particle emitter. And when Americium 241 emits alpha particles, they ionize oxygen and nitrogen molecules in the air, which just means adds or subtracts electrons from nitrogen-oxygen molecules. So if smoke is present, the alpha particles cannot add or subtract those electrons, and an alarm is triggered in the smoke detector telling people that there's smoke and that they should evacuate. So the answer to this is, yep, you have radioactive particles in the smoke detectors in your house. So let's write the alpha decay equation for this. You may have found in the Nearpod that alpha is symbolized with this Greek letter A, and it's equivalent to a helium isotope with a mass number of 4 and an atomic number of 2. So alpha particles are helium particles with 2 protons and 2 neutrons, equaling a mass number of 4. So to write an alpha decay equation, the first thing I do is I write the symbol for Americium. And to find that, I look on my periodic table, and I can see Americium down here like this. It's number 95, meaning it has 95 protons. So I'm going to put 95 down here. And I get the mass number from the number that's listed by the element, which is going to be 241. And it's going to undergo some decay. So when I'm decaying stuff, there's only one isotope on the left side of the equation and 2 or more isotopes on the right side of the equation. So it's going to emit a helium isotope. So on the right-hand side, I put helium with a mass number of 4 and atomic number of 2. And since I took a helium out of the Americium, I'm going to subtract the atomic numbers. 95 minus 2 makes 93. So whatever my new radioactive isotope is going to have an atomic number of 93. And 241 minus 4 is going to be 237. And that's going to go on the top. So my last step here is to decide which isotope has an atomic number of 93. I'll get back out my periodic table. Look down here. It is element NP, neptunium, that has an atomic number of 93. So NP goes here like that. So you don't have to show the work where you do the subtraction, but the important pieces here are having what you start with on the left-hand side. Sometimes we call that the parent isotope. Here is your alpha particle, and here is what we sometimes call the daughter isotope. And in this case, it's going to be the neptunium. And then the arrow just shows that decay is occurring. Hopefully this will help you write alpha decay equations for particular problems you will find in the Unit 5 Week 2 folder. Thank you for watching. Have a wonderful day.